Factoring first. Sometimes I personally find things are more difficult to factor when you have a negative in front of the x squared. So if you would like, you can factor a negative out of the whole thing to begin with. And that may or may not, depends how you are, may make factoring that easier. So to get 2x squared, the only possibility to get 2x squared would be a 2x and an x. To get positive 2 would have to be 2 or 1 and 2. It's going to have to be 2 and 1 this way. They're both going to have to be negative. That way I still get the positive 2, but when I look at the outside and the inside combined, can you see that I'll get minus 4x minus another x? That matches up with the minus 5x that I have right there. So this is factored completely. Does anything cancel out? No. So when we look at step 1, when we write out our non-permissible value, that x can't equal 1, we know that this is going to turn into a vertical asymptote. When we look at the highest powers here, the highest power on the top is an x, or the highest power in the whole thing is x squared. We have negative 2x squareds on the top. We have no x squareds on the bottom. This is not possible to divide by 0. That's telling you you have an oblique asymptote. So we have a little bit more work to do to find that. To find your oblique asymptote, set up synthetic or long division. This one, since we're dividing by x minus 1, works with synthetic division. We would have negative 2. We'll use our original equation, positive 5, negative 2. Bring the negative 2 down, add. Of course, the remainder doesn't matter. Our oblique asymptote will be y equals negative 2x plus 3. Just using this part, because the remainder of 1 won't make a difference. Step 3, our intercepts. Our y-intercept, if you plug in 0 for x, you're going to get negative 2 over negative 1. Y equals 2. Our x-intercept, again, when you plug 0 in for y, you want to find out where your numerator is equal to 0. That's easiest to check right here when our numerator has been factored. Can you see that our x-intercepts are going to be x equals 2 and x equals 1/2. And we're going to check now if we have enough information to graph. Asymptotes. We have a vertical asymptote at x equals 1. We have an oblique asymptote at negative 2x plus 3. So we'd have a y-intercept of 3, a slope of 2. So you need to go up 2 over 1 or down 2 over 1. Yes? Oh, yes, thank you. It's a negative 2x. So, down 2 over 1. Can label these. So this is x equals 1. This is, and as soon as, and that's one of the nice things about labeling a graph. As soon as I would have labeled that line and noticed that my slope was supposed to be negative and I drew a positive slope, it would have alerted me that, hey, something's not quite right here. So now we've got all of our asymptotes shown up. We can draw in our points. We have x-intercepts at 2 and at 1/2. We have a y-intercept at y = 2. So if we look at our asymptote, this time it's our vertical asymptote is going to separate our graph into 2 sections. Sometimes people think that there's 3 sections because of the oblique asymptote, but the oblique asymptote's just for drawing. It doesn't separate your graph into another section. Just like horizontal asymptotes don't separate your graph into another section. So do we have stuff left of x = 1? Do we have points left of x = 1? Yes. So we can draw towards our asymptotes for that section. Do we have something to the right of x = 1? Yes. And since it's in this part, we can draw it towards our asymptotes. So you didn't need to do any further points. You didn't need to check your asymptotic behavior because it was obvious from with the points that you had where your graph was going to go. Question number 5. Seems to be a pattern here, 3, 4, 5.